go. So yeah, thank you, Lauren, for that wonderful introduction. As you might have been able to tell from that, I have some of my own opinions, which can be sometimes controversial. So hopefully you'll get some interesting, thought-provoking ideas out of this talk. What I want to be talking about today is this idea of whether blockchain has sort of brought us together and helped connect the world, or whether it's actually so far been actually somewhat divisive. And I'll kind of go into why I say that and some personal experiences that have given me at least that sort of taste. From there, I want to talk about some ways that we can maybe direct these energies into a better direction, where we think about interoperability and bringing all these different efforts that we're here to talk about closer together to make it easier for people to adopt blockchain. So it's not like I have to adopt this technology or that technology, but rather tying these things more together, so it's more I can just build on it and not have to worry about which particular stack that I want to use. And then finally, I want to talk a little bit about, there's a lot of investment going on in the blockchain space, and obviously I can't, tell you what to invest in, nor would I want to, but I think that it's important to have sort of a framework of how to think about these things, and some of these topics that I'm talking about have implications for investments, so I don't want to leave you without at least some thoughts on that topic and kind of how you can apply some of what you've heard, practically. Yeah, and without further ado, the way that I kind of got into the blockchain space originally was from a perspective of payments. So I used to work in London at a small web agency, and we used to have freelancers sort of all over the world. We had very few full-time employees, like a handful of full-time employees, and then most of the work was done by freelancers. And one of the issues with that is that now you have to pay those freelancers, and they're in places like Pakistan, they're in places like Nigeria, they're all over the world, and sometimes the payments can be quite painful. I remember there was one person in particular who was a designer in Pakistan, and he was always doing fantastic work for us. We loved working with him. He was excellent. But one day, the company we were using to pay him, the payment provider, actually pulled out of Pakistan for risk reasons. And so we did some research, tried to find an alternative, and the best thing we could come up with at the time was Western Union. And so we kind of did the math, and it was just not cost effective to pay him on that new basis. And so we ended up not working with him anymore. And I remember thinking that that's just the worst reason to get fired. Just payments friction, and so it's always been on my mind to think about, is there something we can maybe do about this, something to improve this problem. But if you kind of look at the financial industry from the outside, if let's say you're an individual developer, or whoever you are, it's this huge industry, very conservative, and with good reason. They're managing our money, and you don't want that stuff to break. But how do you go about making any change happen? And it's actually kind of interesting to hear some of the conversations that I've had now with people in the payments industry who have tried to make change happen and the sort of obstacles that they've run into. And so really what was needed was sort of a push, something that got us all going, got us all out of the gate in terms of how do we even tackle these problems to begin with. And for me, that was Bitcoin. So I got into Bitcoin in 2010. At that time, it was sort of a small community of very crypto-focused people, really, really awesome community, some of the smartest people that I've ever met before or since. And in that time, I sort of dived in head first. I immediately went full-time on it, was, I think, one of the first people to do that. And I was just so in love with it. And I'm sure a lot of people here can relate to that feeling of there's just something about this technology that's incredibly fascinating. And so it kind of went on like this for a while, and I started to go to conferences. There was a video that I helped produce called What is Bitcoin? That got fairly popular, and then I made a website around it, which I don't run, by the way, anymore, but it kind of got a lot of people turned on to the technology, but then I kind of saw a lot of them drop off, not really manage to get onboarded and use it. And so I started to think about the usability of this technology, and also kind of what it would take to take it from where it is now, or where it was back then, and take it to the mainstream. And so I started working on Bitcoin.js, so you could do Bitcoin things in the browser. Keep in mind, this is before most of the altcoins came out, this is before most of the alternative sort of private blockchain things came out. And so I always felt like I was still running up against a wall. And what's more, I also started to notice that the more I was trying to fix things, the more I would get a headwind from inside the community, which is kind of odd. You know, you think like if we're all in the same boat here, we're all trying to do the same thing. For instance, when I joined Ripple, which was kind of trying to make blockchain faster, more efficient, and so on, a lot of people were like, hey, you know, like you're a trader. I'm like, what? Why am I a trader? What did I do wrong? And so you can see this as a general theme, right? There's a lot of animosity between different coins. More recently, there's been animosity within even Bitcoin itself, where people are kind of like, well, we should take it this direction, we should take it that direction. There's a whole like Bitcoin versus Bitcoin Cash. And so I was kind of, why is that? Because my background is sort of in the web space, the web developer space, and you get very little to none of that, where it's kind of, you know, everyone can kind of experiment in their way, and then when something good pops up, other people just adopt it. But with Bitcoin and with blockchain, it's always been much more, I felt much more, you know, aggressive, you know, kind of it's me or you kind of thing. And so I was kind of thinking about that, and I was like, where did we go wrong? Like, why is this technology different? And why is it that we have to, why is it so political? Why is it that we have to fight each other all the time? And I think the fundamental reason is that blockchains are this sort of monoliths. So I'm either on this stack or I'm on that stack. And so what do I mean by that? Like, what kind of stack am I talking about? Well, this could be like your Bitcoin stack. You have an app that's built on payments layer, which is, let's say, Lightning, and then there's a currency, let's say Bitcoin, and then that currency has certain economics and has a certain way to achieve consensus, and then there's politics behind that, like how do we change that and how do we change the rules of the network and so on. And so if I want to use any of those apps, I pretty much have to subscribe to that entire stack, even though I might not agree with the economics, or I might not agree with that particular consensus mechanism, or maybe I have an issue with the politics. And so I think that's one reason that makes it so divisive, is like, you know, all the Ethereum people out trying to get people to build on Ethereum, and then you have Tendermint people trying to get people to build on Tendermint, and all these kinds of things. And so how do we get to a place where maybe some of these things are a little bit more interchangeable, a little bit more interoperable, so that I can use the ledger that I like and still use your app, even if it's built on a different stack. And in order to solve that problem, we could take some inspiration from the internet, because the internet does exactly that. If I make an app that can, let's say, do phone calls over the internet, I can use that on my local wired network. I can use that on my local Wi-Fi network. I can use that over the public internet. I can use that over a satellite network. It really doesn't matter what the underlying infrastructure is, because the app is just written against the internet protocol. It's not written against a particular network technology. And so the internet essentially acts as this abstraction layer. And so we kind of looked at one slice of the blockchain space, which is payments, which I think is a very important slice, because payments kind of underlie a lot of other things. When it's anything related to incentives or smart contracts, usually involves payments. And so we kind of tried to apply the same idea to the blockchain space. And so what you would get if you did that was you'd have apps that are written against this payment layer, and then you can have all your different blockchains underneath that, and they can have their own currency, they can have their own economics, they can have their own consensus mechanism, and they can have their own politics. But the apps kind of work with all of them. And so that's sort of what it would look like in the abstract. And you know, this is kind of an idea that we had 4 years ago, and we've been working on it since. And so what we came up with is this set of protocols called IntelliJ. And basically what it does is it allows you to describe what you're trying to do. So you can say, I'm trying to get money from, you know, this account on this ledger over to this account on this ledger. And IntelliJ will try to abstract the differences between the individual ledgers away from you, so you can make that transaction no matter what's happening behind the scenes. And I think the biggest challenge in developing this protocol was ledgers are very different. And so trying to make something like Bitcoin look the same as something like XRP Ledger, look the same as something like a mobile money provider, is quite challenging, because they all have different feature sets, they all have different capabilities, very different speeds, very different fee structures, and we really wanted it to be universal. Like, it's not like the internet if it can't run on everything, not just blockchain, but you know, bank services and things like that. And so what we ended up with is basically abstracting the actual funds movement from the communication, the data exchange that happens around the payment. And so in a modern sort of IntelliJ implementation, what happens is that I'm basically sending a packet of data, which is just here's the amount, here's the destination, and here's some attached data, and I'm sending that to the receiver. And then at each hop, people keep track of how many packets have you sent, and then settle up later. And one cool thing that blockchain allows is if I have a ledger like XRP or I have a technology like Lightning, I can actually settle each individual payment. So I take almost no risk. I can send this entire packet all the way through, and I have very little risk doing that. If I want to go over something like ACH or SEPA, which is sort of the settlement systems in the US and Europe, it gets a little bit more expensive and a lot more slow. And so I might settle less often, so that I'm taking on more risk with respect to my counterparty, but otherwise it still works the same. And so that's the only way that you can really achieve the complete abstraction of whatever you're using underneath. Another thing that you see sometimes is that there are sort of multiple settlement layers. So this ACH payment might be settled by FedWire or some other technology at some point in the future. But from a perspective of IntelliJ, it's just the ledger's abstracted away. And now I have this sort of layer where I can send these packets, and they're going to get there almost instantly, again, no matter how slow the underlying ledger is. And they're going to get there at a very competitive rate because the actual payments, if they're expensive, could be bundled up. And so the fees kind of get spread out over lots and lots of packets. And so I can actually send packets very efficiently. So just to kind of plug in what actual implementations of this look like. So we have built a sort of prototype of this called IntelliJ.js. And we worked with the Bitfury guys to integrate Lightning. We're working with a team called Machinomy. They're building Ethereum payment channels to integrate Ethereum. And then, of course, working for Ripple, I made sure that XRP Ledger supports this as well. And so you can now basically download plugins for all of these different systems and then use IntelliJ on top. And again, you can use whatever system you want. The counterparty you're transacting with can use whatever system they want. And IntelliJ kind of makes up for all the differences. And of course, the idea is to expand it further. So there's a group called Everest. They're building a project called Hyperledger Quilt. And so that's a project to essentially make all the different Hyperledger projects compatible with IntelliJ, so that if I have, let's say I'm an enterprise and I have a private blockchain, and now I need to make transactions between the public IntelliJ that involves some of these digital assets and my private ledger that's running on, let's say, Hyperledger Fabric, I can use Quilt to provide the integration. There's also, of course, Ripple's bank offerings, and the idea is to make those ILP enabled as well, ILP being IntelliJ protocol. And finally, I want to talk quickly about this project called Mojo Loop. So Mojo Loop was a project that we started about 2.5 years ago together with the Bill and Melinda Gates Foundation. And the idea was Bill and Melinda Gates Foundation wanted a solution to provide national level payments interoperability. So the idea is that you have a country like Tanzania, and they might have some amount of interoperability between different payment providers, in this case, like the top 3 or 4. But then there might be other providers, like in Tanzania's example, like HaloPay, that are not part of that group. And as a result, there's sort of friction in the payment system and not enough competition. And so they did a lot of projects in different countries to try to bring down the cost of digital financial services to get more people access to the financial system. However, what they ran into is, like, if they were very successful, they ended up creating a monopolist. If they were not so successful, they ended up fragmenting the market further. So you would have, like, merchants have like 3 phones and juggling them around to try to figure out, what system is their user trying to pay with, and how, do I have the right phone for that, or the right SIM card for that? And so what they realized was what makes the communication space so competitive is the interoperability part. The reason that everyone in sub-Saharan Africa or a lot of people can afford cell phones and feature phones is because there's a lot of competition for that market because there's interoperability. Any cell phone provider, you can make calls to any other one, and so it doesn't matter which one I sign up for. Whereas with payments, that's not the case yet. If I sign up for one payment provider, that doesn't necessarily mean that I'm going to be able to send money to all of the other ones, let alone send money internationally, like making an international phone call. And so interoperability is really the key to drive down costs. That's actually something that I learned also being in the blockchain space for a long time. I always thought that it was sort of decentralization that brings down cost. But then last year we saw Bitcoin's fees skyrocket. And so really what keeps the fees low is the competition, people switching to other systems and having alternatives. So that's why interoperability is so key if you want to bring down costs, if you want to add financial inclusion. That's an example of one project that can cover sort of a whole area of the financial system that would otherwise be very difficult to cover. So I wanted to highlight that. Now, let's say we have this layer. Let's say we have this abstraction layer, IntelliJ, and we can make payments across all these different systems. What can we do with that? Like, what's the end goal? What's the end game? And so one of the things that we did was, on the internet, you have this technology called TCPIP, and specifically the TCP part. And what that means is it's essentially a protocol which takes what the internet allows you to do, which is send these tiny packets of data, and it allows you to send larger amounts of data because it will deal with failures, like a packet gets lost, it'll resend it. It'll deal with packets arriving out of order. It'll deal with just your data being too large to fit in one packet. And so TCP gives you sort of a tool set of things that make IP a lot nicer to use, if you will. And so then when you build your app, you don't have to reinvent all of those technologies. You can just use TCP and be done with it. And so with IntelliJ, we actually need something similar. So if we want to make a larger payment, and in the case of IntelliJ, we actually think of the packets as being fairly small, so they could be, we don't know what people will ultimately end up with, but they could be maybe $1, it could be $5. And so if I want to make a larger payment than that, I have to think about, okay, well, how do I use this, what IntelliJ gives me, and then build a larger payment on top of that. And so we came up with a protocol we call PSK, which basically does this sort of same kind of disassembling of payments into individual chunks, sends those chunks over IntelliJ, and reassembles it. And that's like, okay, great, now I have that level of capability. What can I do with that? Well, we built a demo using the W3C payment handler API, which basically shows what maybe a retail payment flow would look like on top of IntelliJ. So the idea here is that you have your phone, you download an app, let's say it's a crypto wallet. And the crypto wallet registers itself as a IntelliJ capable wallet. And so now your browser knows and your phone knows that, well, you have an IntelliJ capable wallet. So let's say you go to a merchant, you buy a slick leather jacket, and you need to pay. The merchant can call a browser API that's actually already rolled out, which is the payment request API. And that kind of, the merchant can say like what payment methods it supports. And if they include IntelliJ in that list, then the phone will recognize that there is a match, and it'll offer it as one of the options. And so from the user's perspective, they don't have to know that there's this match. They don't have to know that there is, if the merchant has IntelliJ and they have IntelliJ, sometimes people call that sort of the NASCAR effect, where the merchant has to have like 1,000 logos on their website to show like all the different payment methods that they support. And so instead, you just sort of select the one that you want and you go. And so this is one example of like what a user experience could look like that you build on top of this technology. And what's cool about it is, again, this is not a Ripple payments protocol. It's not a single ledger solution. It's a solution that could potentially work for PayPal. It could potentially work for, well, it does today work for Ethereum and Bitcoin. And so this is sort of a protocol that we can work on together as opposed to having to say like, no, you should use my thing instead. Another example of like what you can do with this sort of technology is, today if I want to use a paid API, so let's say I want to use Azure storage to upload some files. What I usually do is I'd go to their website, I'd give them my credit card information, and they'd give me some kind of API key. And then with that API key, I can make calls to the API and it'll do things for me. And the only issue with that is that there's a little bit of extra friction, and maybe on the back end there's a lot of friction. So for example, we heard this story about Uber. And basically what they do is they have a big relationship with Twilio. For those of you who don't know, Twilio is a service that sends out text messages. It has like, phone systems that you can call into and things like that. And so companies use it to set up their like, interactive phone systems and SMS and so on. And so Uber obviously uses them a lot. And so they get like a big bill at the end of the month. And then they have to kind of figure out like, okay, which services that we run is responsible for which parts of this bill. And so they basically have to reconcile manually the sort of PDF document with all of the different services and what they've been doing to make sure Twilio charges the right amount and so on. And so what would be really nice is if you could actually just make payments part of the interaction that the service does. So let's say a certain web service at Uber has a certain budget. So that means that they basically just create an account for that service on their internal payment system, or their internal accounting system. And then when that service makes calls to Twilio, it just includes the payment with the call. So there's no additional billing after the fact. So there's no more steps. It's all updated in Uber's accounting system. It's updated in Twilio's accounting system, and the API call is done. And this wouldn't have been possible before because there's so many different payment methods. And so if Twilio wanted to offer that, they'd have to say, like, well, we offer this for people that pay with PayPal, but it wouldn't work for people that pay with credit card directly, for example. But by having a standard, now you can say, well, we rely on the standard to make this tiny payment, and so as a result, people can adopt it at scale. And so that's why I think it's really the missing piece. It's like we can build all these cool apps that use blockchain to solve incentive problems. You know, think of, let's say I'm making a mesh networking service, and I want to make sure that the different nodes pay each other for the traffic that they route. And now today, like I have to build that on Lightning, or I have to build it on one particular technology. There's no abstraction layer that kind of lets it ride on PayPal or Lightning or whatever I want it to run on. And so that's really what I think is very powerful, and one of the missing ingredients to really take blockchain mainstream. And so you can think of like all kinds of use cases for this. Now the question is, like, I kind of promised that I would talk a little bit about what this means for different tokens, and so we'll spend a few minutes talking about that. And in order to kind of wrap our heads around that, I came up with a sort of a very crude way to categorize tokens. And so I kind of have the ones that I think of as currencies. These are tokens that are meant for users to use to pay each other, right? So one example might be Filecoin, where I, as an uploader, send you some Filecoin, you as the host, to host this file for me. So this would be a currency that's used as a currency, as a token that's used as a currency. And then you have the sort of shared network tokens, where something like Ether, where I'm paying not a particular person in that system with the token, I'm paying the system itself. And then as a result, because it's a shared resource, it acts as sort of a deterrent for spam and things like that. And so you basically use the token as a more convenient to pay like a large number of people all at once. And the third category is this idea of like a token where there's actually a counterparty. So this would be your loyalty points, this would be your centrally issued tokens. And so one example would be Globitex, which is an exchange, and so they did an ICO, and so if you hold that token, you can use that to pay the fees on the exchange. And so the way that these things traditionally work, so for example, if you think of American Express, they have a loyalty program, American Express points, and so for them, that's just a liability on their books. So there's actually a company that's liable for these tokens, and so your main risk is that that company won't be good for those promises. So I think these kinds of backed tokens are pretty easy to understand. They're nothing that new. They're just sort of a more liquid form of gift cards or something like that. So I think we can, move on from them pretty quickly. I think the shared system tokens, if you want to think about how valuable those are, you have to really think about how valuable is the system that underlies it. So if I want to know how valuable is the Ether, I have to think about, well, who's going to use Ethereum as an alternative to something else? So somebody that might today have a system that they maybe run at like a IBM Bluemix or Microsoft Azure. What's going to take it? What is it going to take for them to move that onto Ethereum and run it on the blockchain? And of course, you have to think about, like, there's going to be a lot of competition all the way along the spectrum, right? So I'm sure that Azure is going to come up with new services that maybe have some aspects of blockchain. Maybe they use something like Hyperledger that gives you some of the benefits and some of the decentralization at a much more competitive price point. And so that's kind of how you should think about whether these tokens are valuable. Is like, are people going to use that shared system because it has a strong advantage over, centralized alternative or maybe a semi-decentralized one? And that gets me to the most interesting category, in my opinion, which is currencies. Currencies are weird because it's almost like you can have a currency that has no backing at all, right? So if suddenly everyone stopped accepting US dollars tomorrow and I wanted to get my money back, get some actual value behind it, I wouldn't be able to. Like, there's nobody that's going to give me gold, there's nobody that's going to give me anything for it. It's only the fact that it's currency, only the fact that it's widely circulated that it has value at all. And I think the same is true for certain digital assets. So I think both for XRP and Bitcoin, the primary value proposition is as a currency. It's something that I can use to transmit money, to transfer value around. And so the question you have to ask yourself is this asset going to be successful as a currency? Now, with currencies, what's the primary driving force is the amount of acceptance. Sometimes you say liquidity, sometimes you say, how widely is this currency being used? And that's kind of the thing that you'd want to look at. Specifically, when you have different use cases for currencies and different tokens that are targeted at different use cases, you should think about, are those use cases, do they have a lot of internal transactions? Because if they don't, that means that those tokens are more directly in competition with more general purpose tokens. So for instance, if you have a token that's only used for hosting, then the file uploader is going to think about, well, I'd rather use something I don't have to buy first, right? Like if I already have Bitcoin, I'd rather pay with Bitcoin than with, X token. And the same is true for the file host. They'd rather accept something that's more easily to turn into dollars, more easier to turn into dollars so they can pay their electricity bill and hosting bill and so on. And so when you have money kind of entering the system and then immediately exiting, it's much harder for a special purpose token to actually compete with general purpose token solutions. And a lot of times, like these protocols that these tokens are used for are open source. So there's nothing stopping anyone from either forking the project and adding the capability to have other tokens used, or just straight up making a competitor, right? So it's very difficult to see, if it's a special purpose token with a system that has not very much internal circulation, how that would compete against more widely used tokens, more liquid ones. And then at the other end of the spectrum, you kind of have systems where there is a lot of internal transacting. So money enters the system, then it goes around in a circle for a while, people trading with each other, and then finally it exits. And so some examples I was able to think of are gaming and gambling, where people kind of cash in, then it stays in that economy for a while, and then it leaves. And funnily enough, like those are exactly the kinds of use cases where you already see virtual currencies used today, because it makes sense. You can have a currency just for that system, and you don't add a lot of friction because the cash in, cash out is a pretty rare occurrence, so you don't need to constantly worry about it. So that's kind of some thoughts on, if you look at a token, you kind of think about what is this worth, some ideas you can apply. So yeah, that's it for the talk. And I don't know if we have time for questions, but otherwise I'd be happy to take some questions. First of all, to the organizers, how are we doing on time? Oh, wow. That went way too fast. All right. All right, let's take some questions then. It's my favorite part anyway.
Is the XRP token needed to actually operate a real-time gross settlement system that's essentially a closed ecosystem?
Yeah, so with everything that we do, the idea is always like we try to make the payment space more competitive. So we try to reduce friction wherever we find it. And then the idea is that if you have a very competitive system, the best ledgers will tend to rise to the top. The best ledgers will tend to be the ones that people use. And just to explain why that is the case, if you think of, there was this one conversation I had with a very large international bank, and I was kind of walking them through how we could reduce their costs by like 30, 40%. And their response was like, look, we charge our customers 40 basis points. Our own costs are only 2 basis points. So reducing costs is not important to us. However, if the system is more competitive, if there's more pressure on them to lower costs because their customers are switching to other alternatives, because the whole system is interoperable, and so you can use different paths, and the cheapest paths are the ones that are selected, that actually puts pressure on them to, first of all, lower the amount that they charge, but then also like lower their own costs. And so, for instance, today in the blockchain space, I think people are going at it with a very sort of, I'll call it an ideological viewpoint, where it's like, hey, at some point in the past, we convinced ourselves that decentralization is important, so now we're just going to like use the most decentralized thing. And it works great if you're doing tests. It works great if you're just doing experiments. But if you're actually running a business and you're actually trying to, route your customers' payments at the cheapest way possible, then you're going to think about, okay, well, what ledger gets that accomplished at the price point that makes me the most money? And so our approach has always been to try to increase the competitiveness, and we think that that will naturally lead people to the kinds of ledgers and the kinds of technologies that we provide, including XRP, but also like our software for enterprise.
I have a question. Given all the politics around the different sorts of currencies, it seems that investors tend to choose the currency and then become very emotional about it. As you said about there's the Bitcoin Cash and the Bitcoin debate. Do you see a world in the future where there are a plethora of these currencies that all operate independently and have their own niche markets, or is it more likely that most of them will disappear and there'll be only a few dominant currencies that exist? Do you think that we're going to still have a world in the future where we have literally thousands of currencies?
Yeah, it's funny because I think interoperability kind of works both directions, right? So on the one hand, it makes it more viable to have more currencies because it's easier to interact with people that aren't on the same system as you. So for example, if you're thinking of payments today, a lot of retail payments go through one of the large card networks. If you had a lot more interoperability, there's a pretty good chance that it might be other paths that your payment goes, and you wouldn't think about that. It would just be what happens. And so you could definitely see a lot of decentralization happening through interoperability. But on the flip side, it also puts all the different providers, which includes the currencies, into more direct competition with each other. And so as a result, if there's currencies that are inefficient, or if there's currencies that don't work well, or they have bugs, or they're down all the time, people will probably be more likely to switch. And so it could also lead to some level of consolidation between the different assets. Ultimately, what the difference that it's gonna make is that the user's experience is gonna be the thing that everyone optimizes for. So it's no longer what would we want from some sort of theoretical standpoint, but what are users actually choosing to use, what are users actually going for. And again, that's why I think it's so closely tied to taking this type of technology mainstream is, I know it's how nice it is to be in the lab and, to play with this technology and not have that pressure of like, oh, I'd like it to work this way, but then it's a little bit slower and my users don't like it. But ultimately, to take something mainstream, you have to kind of let go of it a little bit and say like, what do users actually want? What do they actually care about? Not just what do I want in some abstract sense. Yep.
You speak a lot about currencies, but in order for us to get mainstream, I'd love to hear your views on how fiat currencies and mainstream currencies that are used today interact with cryptocurrencies.
Fantastic question. So the question is, how do fiat currencies fit into this view, and how do they interact with cryptocurrencies? Now, that's actually a topic that's been very close to my heart for a very long time. All the way back when I joined Ripple, one of the main reasons was because Ripple had the ability for fiat assets to be issued on the ledger and for fiat assets to trade against the crypto. We later kind of decided that if you have to issue assets onto the ledger first, that's not good enough because a lot of banks, for various reasons, don't want to have assets issued on all kinds of different systems. And so to get true interoperability, you actually need a protocol that can sit on top of different kinds of ledgers. And so one very, very important goal with IntelliJ was specifically what you're kind of hinting at, or what your question is targeted at, which is make sure we support fiat assets as natively and as well as digital assets. And ideally, without requiring a huge shift in technology in terms of how these fiat assets are transacted and transmitted today. So just to give you sort of an idea of what I'm talking about, like if I use IntelliJ, as long as there's a provider that I'm using it with, I can settle with that provider, the sort of green boxes that you saw moving around earlier. I can settle with that provider literally with a bank wire or with a direct debit or whatever we would use for something like PayPal today, and it will work just fine with IntelliJ. And that's why I think it's so important to have that kind of interoperability protocol. It's not just a blockchain interoperability protocol, but it is a general payments interoperability protocol. And again, I've been talking a lot about IntelliJ. I think that there are other use cases like smart contracts and other things where there's an opportunity to create protocols like that that are more general and that are able to link the blockchain world with the, I was almost tempted to call it the real world, but with the legacy technologies.
So yeah. Look, I don't know if I understood all of that. So at the risk of sounding stupid, does the IntelliJ, is it going to allow a person, a buyer, to pay with one currency and the seller to receive it in a different currency? And if so, how does the exchange rate work between those currencies?
Yeah, so you saw that an IntelliJ transaction is sort of this chain, and the nodes that are in the middle of the network are called connectors. The closest analog in the internet world would be a router. So what connectors do is they receive packets, so you might send packets to your IntelliJ service provider. They receive your packets, they see what destination is on there, and then they decide what is the best next hop based on the routing information that they have. So there's a routing protocol, they populate routing tables and then route it in the right direction. Okay, so let's say a connector knows which direction they need to route a packet to. The next thing is, as you asked, the exchange rate. And so for each connector, basically what they do is they get in a packet on one side, they look at the amount, and then they look at what link am I going to send this out on. If it's the same currency, then they'll just apply maybe a fee, maybe no fee, and then forward it. Or if it is a different currency, they'll apply the exchange rate, their current exchange rate. They'll apply their fee and then forward it. And so what happens is, whenever you send money onto IntelliJ, there's some amount that's going to get to the other side. So with each packet, you're going to send off with some amount, and then some amount is going to be received. Now, the recipient has the option to either accept the packet or reject it. If they reject it, everything's rolled back, no money has been transferred. If they accept it, then the transfer becomes final, and the money's been transferred. And so what we do in the next layer up, kind of the TCP equivalent, is we handle things like fluctuating exchange rates. So for example, you start a payment, and then while you're making the payment, the exchange rate moves. What should you do? We handle things like refunds. We handle things like outages. So like, maybe the connection goes down, and you can't send packets for a while, and then it comes back, and you have to send the rest of the packets, things like that. And so there's probably not enough time to go into all of those details, but the idea is that similar to the internet, the base layer IntelliJ gives you a certain level of quality of service, like you can get money through, and then a lot of the niceties that we associate with like a modern payment system is actually accomplished on the transport layer. And what that does is it keeps the core of the network very simple and keeps a lot of that complexity out of the connectors, if that makes sense.
Excuse me, can you just expand maybe on the Mojo Loop project that you have? Is there penetration in regions already, or is it experimental?
So the current status of adoption? Yeah, so right now, I would say it's primarily in the blockchain space. So we have integrations with most of the major cryptos. And we actually very recently finalized the IntelliJ protocol itself. So that protocol is now done, final, and won't change anymore. We're still working on the next layer up. So you saw the kind of splitting payments and recombining. That's still something that's going to take a lot of tweaking. People are still working on TCP today. So it's probably never going to be fully finished, but it's something that, it's getting to a workable state. And so the next step is kind of to expand both in terms of the ledgers that we support. And of course, the next step past blockchains, public blockchains, is maybe some of the traditional finance, maybe some private blockchains, things of that nature. Mojo Loop, they're out basically talking now about deployments. So they're kind of looking for countries interested in deploying this. Happy to make contacts there if anyone here is interested. And so it's kind of like expanding the set of ledgers. And then in parallel, we're not going to wait for that. In parallel, it is building apps on top of IntelliJ. And it's really the apps, I think, that's going to drive the adoption, where once you can do cool stuff with it, that's what gets people interested, and that's what gets people to play around with it. So we have a couple of projects right now. Won't go into all of them, but one, for example, is sort of a file hosting protocol where I can upload files and I can pay with IntelliJ. And because IntelliJ payment is standardized and it's sort of an open protocol, I can upload files to a lot of different hosts and not have to trust or rely on any one of them. And it's just orders of magnitude simpler than if it was sort of a distributed system I had to build first to then build this protocol on top of. So there's use cases like that we're exploring, and if you're interested in that, just go to the IntelliJ.org, and there's a mailing list and things like that you can sign up for and stay in touch and figure out what's going on with that. All right.
A quick question over here.
Yes.
My name is Farzam Hassani. Thanks so much for your thoughts. Question on IntelliJ protocol. So whenever I've seen it presented, it's generally done, as you've just mentioned, in a chain, from one ledger to another ledger. The challenge that I see with that is that every single time you go from one ledger to another ledger, in financial speak, you're crossing the double. You're paying the fees, and you're crossing the bid offer, and you're crossing the bid offer, and you're crossing the bid offer.
Yeah.
And if you do that, it gets really expensive, let alone all the challenges that you have with making sure that you lock in all the interests or the exchange rates at every point. So when I conceptualize this world, I think about not a linear process, but a circular process, where actually if you just have a centralized party that has access to all of those different ledgers, and then you can cross the double once, then surely that would be cheaper than what this is happening. So I know there's a lot in this world, we love decentralization, but we also know that there are places and roles for centralized parties. So what would your response to that be?
Yeah. So we did a demo, I would say in the summer last year, which was, we tied together sort of 7 ledgers. And it was, Bitcoin, it was Ethereum, XRP, Chain, which is a private blockchain, and sort of a stand-in for a centralized ledger. And yeah, I don't remember all the exact ones, but basically it's sort of a chain of all kinds of different ledgers. And as we were doing that demo, we basically ran into the exact issue they described, which is, well, the most visible part of the demo is the speed. The speed on different ledgers is very different. And so you get to Ethereum and it takes a few seconds, and then you get to XRP and it takes a few seconds, and then there's other ledgers like the central ledger where it just goes like very fast. And so you're kind of looking at it and you're like, that's not a very consistent, good user experience. It's very hard to build things like API calls on top of a payment that takes somewhere between 0 and 50 seconds, right? Even for something like a retail payment, that might be unacceptable latency, right? Like, for instance, for Visa, their SLAs, you have to respond to authorization requests as an issuing bank in an average of 5 seconds or less. And so really, that's kind of what you have to aim for. And so one of the things we noticed was that one of the hops was really fast, and Bitcoin was the one that was really fast. And the reason was because for Bitcoin, we were like, well, Bitcoin's way too slow to be normally participating in this, so we'll use payment channels. And so the lesson that we took away from that, doing that demo, was we need to use something like payment channels basically for all the ledgers, because that's just so far superior than talking to the ledger and kind of trying to get the transaction confirmed and through the ledger every time. And so we basically ended up with sort of 2 ways to integrate. One is more traditional net settlement, which is we send as many packets as we want, and then at some point we net them all, and then we send one settlement through that slow ledger. And so whatever fees that ledger charges gets split up over all the different packets that are part of that net settlement. And then for something like a blockchain that supports payment channels, we can do the same thing, except rather than waiting a long time before we net settle, we can use payment channels to send claims maybe after every packet, so very often. And so the total amount outstanding is maybe not as high, and so the amount of trust required is not as high. We don't go quite as far as like Lightning in terms of requiring those channels to be conditional, because in a lot of cases, like the cost you have in setting up the channel and things like that are almost as large, if not larger, than the risk that you're taking on a single packet. And so if your risk is limited to that, it probably doesn't make sense to try to eliminate that risk at even greater cost of complexity. So that's kind of how we think about it. As far as like exchange rates and things like that are concerned, what we're seeing so far with the people that are running connectors so far, a lot of connectors don't charge any fees at all. That's partly because people have other reasons why they're running a connector, and it's actually fairly cheap to run a connector. For exchange rates, they tend to be very competitive because it'll take the cheapest path, and so if your exchange rate is not very competitive, you may as well not run a connector at all. So I think that what's really driven the internet to become as fast and as cheap and as efficient as it is this sort of idea of routing and kind of routing around high rates. So that's how I think about it. To your question, like, could you have a central party that covers the entire path? I think that's totally possible for certain use cases. Like if I want to send a lot of money over between two people, or maybe a really good example I think is escrow, where like I need to put money on escrow, and so I need somebody that can handle that additional functionality, then it probably makes sense to use a central party. I think in a general case, the forwarding thing, if you don't have the ledgers in the actual flow of the payment, but rather net settled, I think is efficient enough, even if it's multiple hops. How are we doing on time?
Can I have one more question?
One more question? All right.
Okay, I'll ask it then. I'm very interested to know that, what the role is for both Ripple and IntelliJ. Would it be possible to replace Ripple with IntelliJ? How do they differ?
Right. Well, so you kind of saw earlier these different technologies that are actual like ledger technologies. And so as Ripple, one of them that we work on very intensively is XRP ledger. So that's a public blockchain. It's a decentralized, open source, neutral protocol, basically for moving XRP around. That's kind of what it does. And so that could be one of the ledgers that you use as part of an IntelliJ chain. Another technology is we have a bank product called xCurrent, and that's something that banks deploy to improve the transparency for their customers when their customers make payments. And that could be another ledger that is part of the IntelliJ that your payments might go through. And so the way I would relate the two is kind of like maybe Cisco and TCPIP, where Cisco did a lot to further the TCPIP stack, and they make a lot of products around that help companies adopt TCPIP in their own networks. And so that's kind of how you could look at the bank products. And then on the currency side, we just think that XRP will do very well in this sort of world. And so it makes sense for us to push this open standard to try to make this whole world more competitive, more efficient. And I think something that we all in this room can benefit from is to take it mainstream.
Great. Well, thank you very much, Stefan. It's a privilege to hear your insights.